Welcome guys. Today we'll be doing some proofs using the properties of determinants. Let's get into it. Now we are going to solve using the properties of determinants. Here we have in column 1, S is common. So what I can do is factor out S out of the first column. So factoring out S is my first step, because I want to prove that a determinant is 0. Now factoring out the S, I'm left with 1, 1, 1 in the first column, while everything else remained as is. So let me go ahead, rewrite what is my second column. Same case, I'm going to rewrite what is my third column. Now, as I'm writing this, you should be seeing that if I add column 2 plus column 3, I will be getting a squared plus b squared plus c squared. And then I could factor that out because it's common. So let me go ahead and factor out by adding first the two columns, column 2 plus column 3. So I'll have my S, then my first column 1, 1, 1. Then I have a squared plus b squared plus c squared because I'm adding column 2 plus column 3. And it will be the same case here where I add b squared plus c squared plus a squared, but I'm just arranging these to have a squared plus b squared plus c squared. Same case here, I'm going to add c squared plus a squared plus b squared, just writing in the order. So I have a squared plus b squared plus c squared. Then the last column remain as is. Now let me remove equals 0 because we're proving that this determinant is 0. So I'm showing it. My next step is to factor out a squared plus b squared plus c squared. Print out, it means I'll have another 1, 1, 1 in the second column. Then the third column remain as is. Now we have a property when two rows or two columns are the same, the determinant of this is 0. So just by looking at this, since column 1 and column 2 are the same, then I can say the determinant of this is 0. The next activity we have, we're going to prove that the determinant of this is equal to 243, open bracket, x plus 3. Now, the first thing we're going to do is add the columns. So I'm going to add column 1 plus column 2 plus column 3. And that will give me 3x plus 9 throughout in column 1. Column 1 plus column 2 plus column 3, x plus x, that will give us 3x. Then rewrite plus 9. And the same thing is going to happen here. Add x plus x plus x. So we have 3x plus 9. Then add x plus x plus x. That will give us 3x plus 9. The other columns remain as is. We factor out 3x plus 9 out of the first column since that is common. And what does that mean is that the first column will now have 1, 1, 1, and everything else remain as is. Now, In this example, I am going to do row operation only due to the fact that I cannot do what I did in the previous example where, adding column 2 plus column 3, I will not arrive at the same thing. So doing the row operation, I'll look at row 2 where I want the 1 in row 2 to be 0. So it'll be row 2 minus row 1. That will assist me in getting the 1 in this first column, second row to be 0. So let me rewrite the 3x plus 9. Now the first row is 1x and x. So doing the row operation for row 2, I'll have 1 minus 1, that will give me 0. X plus 9 minus x, so the x cancels, so I'm left with 9. X minus x, that gives me 0. Now we're going to do another row operation in row 3 minus row 1, in order for us to get another 0. So what I'll do is 1 minus 1 is 0, x minus x, that's 0, and x plus 9 minus x, that gives 9. Now here we have an upper triangle, so the leading diagonal, when we multiply these numbers, we will get the determinant. So the determinant for this will be 1 times 9 times 9. So 1 times 9 times 9, that gives us 81. Then the 3x plus 9, we factor out what's common, which is 3. So we're left with x plus 3. And multiply 3 times 81, and that will give us a 243 times x plus 3. And that's it. We have proven. Thanks for watching, guys. Don't forget to like and subscribe to my channel.